Assalamualaikum. How are you students? I hope all of you are well. Today we are going to start our lesson number 2. It is about the representing rational and irrational numbers, rational and irrational numbers on the number line. Representing rational and irrational numbers on number line. So students, before we proceed further, let me ask you something. Do you know about the number line? I think you have studied this in the previous classes. What about this? This is called what? This is called a line. And this is called what? A ray. What about this? Sorry, what about this? This is a line segment. Do you know the difference among them? This is a line because we can extend it on both sides. What about this? It has a one end point and could be extended on the other side. And what about this? This is a line segment. It means we cannot increase its length. It would remain as it is. So the number line is a line which could be extended on both sides. So we will put arrowhead on it both sides. So do you remember how to represent the integers on the number line? You have studied it in the previous classes on the number line. How we represent the integers on the number line? We will write down 0 at the middle and the positive integers on the right side, and it will go on. Similarly, the negative integers on the left side. This is what you have studied in the previous classes. Fine. So what about this? Can you tell me which is the smallest number over here? On this number line? Yes, -3 is the smallest number. As we go on the right side, the numbers would become bigger and bigger. Fine. Here, 0 is greater than -1, -1 is greater than -2, -2 is greater than -3. So it means as we go on the right side of the number line, the numbers becomes greater. So the number on the extreme left side is the smallest, and the number on the extreme right side is the greatest number. So now we have to study how to represent the rational numbers on the number line. Right? So first of all, we will write down few of the examples to represent some rational numbers on the number line. As in your books, question number 4. Question number 4 is to represent the rational number 2/3 on the number line. So how would we represent this on the number line? First of all, we'll see it is a positive number. So it would be on the right side of the 0. If it would be a negative number, so it would be where? It would be on the left side of the 0. So what about 2/3? You can convert 2/3 into the decimal form as well. 2/3, just to check your answer. So the decimal point, we will introduce a decimal point and a 0. 3 into 6, 18. And our remainder would be 2. Then we will introduce another 0, and how would we solve it? 3 into 6, 18. 2. And division will go on as we will not have a remainder as 0. It means our answer would be 0.666 or 0.67. This was just to find out that where our answer would lie. But how would we represent it on the number line? First of all, this is a number line which could be represented as L. This is a negative infinity and this is positive infinity. Negative positive infinity means it will go on. Fine? Now if I write down it as -1, 0, 1, 2, 3 and so on. Similarly, here the number will go on the left hand side. Now 2/3 is 0.66. It means it is greater than 0 and less than 1. So it lies where? Between 0 and 1. So we have to divide the space between 0 and 1 into how many parts? 3 parts. 3 equal parts. So here we will draw 2 lines and it would be divided into 3 equal parts. This is the first part, second part and third part. So we have to mark 2 by 3. We will count from 0, 0, 1, 2. It means 2 by 3 lies where? At this point. This is what? 2 by 3. Fine. We divided it just to check that our answer lies where? Our answer lies between 0 and 1. As 0.6 is greater than 0 and less than 1. So this is our required point P. Fine. So let us solve another question, other part. So the example which we did earlier was 2.3. It was which type of decimal fraction? It was a proper decimal fraction. Fine. Now let us take another example which is not proper, that is, which is improper. For example, 15 by 7. This is which type of decimal fraction? This is an improper decimal fraction. So how would we represent this type of a decimal fraction or a rational number on the number line? First of all, we will convert this into the mixed form, that is 15 by 7. So 7 into 2, 14. Remainder is 1. So can we divide it? Definitely not. So we can write it in the mixed form. 15 over 7 would be what? 2 whole. This would become whole, 2 whole, 1 by 7. Fine. So this is the whole part, 2 whole. And then 1 by 7th part. Fine. That is the fractional part. So how would we convert it or represent it on the number line? First of all, we will draw the number line L. Fine. Then you will mark 0 and minus 1 and so on. And on the right side, it is 1, 2, 3, 4, so on. As you can see, whole part is 2. It means from 0 to 2. This number 0 to 2, and then you have to convert the space between 2 by 3 into 7 equal parts. Fine? Or you can check your answer in this way as well. Then when you will find out this from the calculator, it would be 2 point something. Fine? For example, 15 over 7. Remainder is 1. We will introduce a decimal point. Then 2.17. Then similarly, the mean will go on. Right? So on. It means our answer lies or our number lies between 2 and 3. That is greater than 2 and less than 3. So we will mark the space between 2 and 3 into how many parts? Into 7 equal parts. For this, we will mark how many lines over here? 6. 1, 2, 3, 4, 5, 6. So the parts we are having between 2 and 3 are how many? 7 parts. 1, 2, 3, 4, 5, 6, 7. And we have to mark which point? 1 by 7. That is this point. So this is our required point P. That is 2 whole 1 by 7 or 15 by 7. As it is 2.1 something. So this is our required point P. This is our required point P. So this is the way how to represent the rational numbers on the number line. We did 2 by 3, we represented this on the number line, and then 15 by 7 on the number line. Now we will see how to represent the irrational numbers on the number line. So here, student, what you have to do is, you will do the remaining parts which are rational numbers. You will represent them on the number line by yourself. That is second part, third part, fourth and fifth. You will represent these numbers on the number line by yourself. Now we will see how to represent the irrational numbers on the number line. So few of the examples of the irrational number are square root 2, square root 3, square root 5 and so on. Before we proceed further, let me ask you something. Have you studied the Pythagoras Theorem? Pythagoras Theorem applies on the right angles triangle. Right angle triangles. So if we have a right angle triangle that is like this, in which one of the angle is of 90 degree. Now if we have to decide about the base and perpendicular, we should know the other angle for which we are going to draw over here, that is angle theta. So the line on which the angle theta, or the side on which the angle theta equal 90 lies, is called what? Base. And the side which is perpendicular to the base is called, or making an angle of 90 degree with the base is called what? Perpendicular. Now the third side which is opposite to the 90 degree. What does mean by the opposite? That is the two sides which contain angle 90 degree are the two adjacent sides of angle 90 degree, and the side opposite to the 90 degree is called what? Hypotenuse. Now what is the Pythagoras theorem? Pythagoras theorem says that square of hypotenuse is equal to the sum of the squares of the base plus perpendicular. Fine. Or we can say, if we take square root on both sides, so it would be base square plus perpendicular square. So to represent the irrational numbers on the number line, you should know about the Pythagoras theorem. Now what we have to do is, can you draw a right angle triangle? Sorry, a right angle on a straight line. How to draw a right angle or perpendicular on a straight line? For this you will need what? You have to take your compass and scale. So if this is a straight line and you have to draw a perpendicular on some point P, how would you draw? You will open your compass, and on this point P you will place your compass or the pointy needle point on this point P, and then you will take any radius and draw an arc like this, or a semicircle. Now from this point you will mark another arc of the same radius as you did earlier, similarly from this point over here. Now by taking these points as center, you will mark two arcs and join point P to the intersection of these two arcs. So this would be what? A perpendicular on this line L. So now, as you have studied about the Pythagoras theorem and how to draw the perpendicular, now we will see how to represent the irrational numbers on the number line. Okay students, now let us see, can we write or split down 2 as 1 plus 1? Similarly, can we split 5 as 4 plus 1? Here we can split 5 as 2 plus 3 as well. But to represent the irrational numbers on the number line, we will split it in this form. That is, one of the numbers should be 1. So this is, we are not going to take 5 as 2 plus 3. We will take 5 as 4 plus 1. We will split the given irrational number into the two numbers in which one of the number is 1, fine, and other of the number is a square of some other number. For example, we can write 2 as 1 whole square plus 1 whole square. So square root 2 could be written as square root of 1 square plus 1 square, isn't it? Yes. Now square root 5 could be written as this 4 could be written as 2 whole square plus 1 whole square. Fine. As 2 square is 4 and 4 plus 1 is 5. So now we will represent these numbers on the number line. First of all, you will draw the number line L. Now what we have to do is, we will mark 0 as our numbers are positive. Our numbers are positive. So 0, here we will have minus 1, 1, 2, 3 and so on. So you can check your answer that we are going to represent square root 2 on the number line. Fine. Let us take square root 5. If you have to represent square root 5 on the number line, so you can check your answer by the calculator that square root 5 lies where. Now, here by Pythagoras Theorem, if square root 5 is a hypotenuse, so this would be what? Our base. Our base would be what? 2 whole square. Base whole square. So base is 2 and our perpendicular is 1. We will always take perpendicular as 1. So here from 0 to 2. This is your base of your right triangle. Then what about 1? Now here you have to use the scale. If you have marked the distance between 0 and 1 as 1 centimeter, so the distance between 1 and 2 should also be 1 centimeter. Similarly, the distance between 2 and 3 should also be 1 centimeter. Now if you will mark the perpendicular, so as we studied how to find out the perpendicular or to draw the perpendicular, here by using your compass you will draw the perpendicular. On the similar pattern, by taking this point as center, you will mark a semicircle. Then with the same radius, you will draw an arc by taking this point as center and then this point as center. Then taking these 2 points as center, you will mark 2 arcs and you will draw a perpendicular. Now, the length we have to take for the perpendicular is 1 unit. So if you have taken 1 centimeter, you will mark 1 centimeter over here. If you have taken 1 inch, you will mark 1 inch over here. So from this point to this point, you will have 1 inch or 1 centimeter, whatever the unit you have taken. Fine. So our base is what? 2 units. This is our base. And this is our perpendicular. So our perpendicular is how much? 1 unit. Now what we have to do? This is the extra length, there is no need of it, as we just have drawn the perpendicular. So this is our required point. We can mark the points as well. This point should be taken as O. We can mark this point as A and this point as B. Now we have to find out square root 5 on the number line. What about this distance? This is what? Is it square root 5? As we studied that in a right angle triangle, if this is a base, this is a perpendicular and this is a hypotenuse, so from this equation we can say the side OB is square root 5. But we have to mark square root 5 over where? On the number line. Now you will take your compass, taking O as center and OB as radius. O as center means you will take this point as a center and you will place your compass, the pointy end of your compass at point O. And then you will take OB as radius and you will mark an arc of radius OB. So when this arc will meet the line L at this point, so this is our required point P, that is square root 5 on the number line. So this is the way how to represent the irrational numbers on the number line. If you have to represent square root 2 on the number line, we will write it like 1 whole square plus 1 whole square. Base would be 1 and perpendicular would be 1. If you have to represent square root 17 on the number line, so this could be written as 16 plus 1, and when in the square form it would be 4 whole square plus 1 whole square. that is base is 4 and perpendicular is 1. Similarly, if you have to mark square root 10 on the number line, so how would you write down? It would be 9 plus 1, and in the square form we will have 3 whole square plus 1 whole square. So don't forget, when you subtract down the given number, it should be, one of the numbers should be 1. Fine? So this is the way how to represent the irrational numbers on the number line. Now you will do the remaining parts of this question by yourself. That is question number 4, part number 6 we have done. Now you can represent square root 17 by yourself and square root 10 by yourself. Okay students, we are going to start question number 6 now. Question number 6 is to represent the recurring decimals into the fractional form. That is, recurring decimals are which decimals? In which the number of digits after the decimal point, this bar on the 5 means that 5 is repeating indefinitely. So the first step for this question is, we will suppose x is equals to 0.555, so on. Now if one digit is repeating indefinitely, we will multiply the above equation multiplying by 10. If one digit is repeating indefinitely, we will multiply it by 10. If two digits will repeat indefinitely, or the group of two digits repeat indefinitely, we will multiply the equation by 100. So for our convenience, we will mark this equation as 1. Now what will we have? 10 into x is equals to 10 multiplied by 0.555, so on. So when we multiply, what would we have? 5.555, so on. And on the left side we have 10x. Now what would we do? We will subtract equation number 1 from equation number 2. First step was to suppose the given number as x. Second step, if one digit is repeating indefinitely, we will multiply it by 10. If two digits will, or a group of two digits will repeat indefinitely, we will multiply it by 100. Now, after multiplication, what would we do? Subtract equation number 1 from equation number 2. That is 10x minus x is equals to 5.555, so on, minus what? Right side was 10x, 10x minus x. Sorry, left side was 10x. What about the right side? 5.555 minus 0.555 and so on. Okay students, on the left hand side we have 9x. So what about the right hand side? When you subtract 0.555 from this, we will have 5 on the right side. Now what we have to do? When we have to find out the value of x, so we have to divide 9 on both sides. Here we will cancel 9 with 9 and we will have x is equals to 5 by 9. And what was the value of x? If we substitute it, so it is 0.5. That is 5 is repeating indefinitely. The bar on 5 means 5 is repeating indefinitely after the decimal point, and our answer is 5 by 9. Now on the similar pattern, if we have, let us solve an example. If we have 0.23 and the group of two digits 23 is repeating indefinitely. So what would be our first step? We will suppose the given value as x. Then the bar on 23 means that the group of digit 23 is repeating indefinitely. That is 0.23, 23, so on. Now what was our next step? If one digit is repeating indefinitely, we will multiply it by 10. If two digits are repeating indefinitely, we will multiply it by 100. So multiplying above equation by 100. So for our convenience, we can suppose this equation as 1. On the left side, we have 100x On the right side we'll have 100 multiplied by 0.2323 and so on. So when we multiply this, we'll have 23.2323 so on. What was our next step? We have to subtract equation number 1 from equation number 2. So left side would be subtracted from the left side, that is 100x minus x. And on the right side we'll have 23.2323 so on minus 0.2323 so on. So when we will subtract this, we'll have what? 23. And on the left side we'll have 100 minus x is 99x. Now we have to find out the value of x. So we will divide 99 on both sides. So dividing 99 on both sides, here 99 would be cancelled with 99 and x is equals to 23 by 99. Now we will substitute the value of x as we taken earlier. So x is equals to 0.23 bar is equals to 23 by 99. So this is the way how to convert the recurring decimal into the fractional form. Fine? So we have converted the recurring decimals into the fractional form. Now what you have to do is, you have to do the remaining parts of question number 6 by yourself. Okay, the last question of exercise 2.1 is question number 5. What is question number 5? Give a rational number between 3 by 4 and 5 by 9. We have to give a rational number between 3 by 4 rational number between 3 by 4 and 5 by 9. So student, if we have to find out a number between two numbers, what will we do? There is a very simple procedure. You will add down these two numbers, 3 by 4 plus 5 by 9, and whatever your answer, if you divide it by 2, you will definitely find out a number between the given two numbers. That is, if 3 by 4 lies somewhere here and 5 by 9 lies somewhere here, so how will you find out a number between them? You will add these two numbers, and when you divide your answer by 2, you will find out the midpoint of these two numbers. So here we will add it. As all of you know the procedure of adding two fractions, we will take the LCM, that is 4 into 9. Here our numerator would be 3. It would be multiplied with what? This is common among them. So we will have 9. And then numerator 5 into 9 is common, we will write down 4. Or if you divide 4 into 9 by 9, you will have 4. So we have to divide this by 2. 9 into 3, 27, plus 5 into 4, 20, and 9 into 4 is 36. Now you have to simplify your answer. How would we simplify it? 27 plus 20 is 47. 47 divided by 36 divided by 2. If we change the sign of division into multiplication, what would we have? That is 1 by 2. Now, numerator would be multiplied with numerator and denominator with denominator. So we will have 47 by 36 into 2 is 72. So this is the required number which lies between, or the required rational number which lies between 3 by 4 and 5 by 9. So here our exercise 2.1 is completely done. You have to practice this exercise. Okay students, good luck and Allah Hafiz.